Hello, this is John Baugh, and this is session 4 of C++ programming. This week, as you can see, the week that I'm recording for is for the 27th, even though today's the 21st. For the 27th, we have Control Statements Part 2. This is in Chapter 5 of the DoWhile C++ How to Program 9th edition. And you'll note that next week we do a coverage of functions, and we have a review of the midterm. Functions are in Chapter 6. I'm also assigning Project 1. The midterm will take place on the week of the 10th. Currently, the major days that I have it set for are Tuesday, June 11th. Several people have suggested that we have something on maybe Monday. I'm going to play around with that idea. If you want Monday or would prefer Monday, I ask that you would put a special post in the discussion board to let me know, and we will try to work out something. Let me know if evening or morning's better, and we'll try to work with that. So that's the midterm so far. So there was a question on the discussion board that I wanted to address. Vadim, or I believe Vadim or Vadim, when building classes in Java, we list data members first and then the functions and methods. I see that in C++ it's opposite. Does it really make a difference in which order we write the class, since the code runs either way? It just kind of makes more sense to define the members first, followed by functions that do the work on those members. So my answer, and I'll expound upon it a little bit, in Java that is typically the case that you will see the fields, or what we call in C++ the data members, the private data members or fields, are at the top of the class in Java. In C++, it doesn't actually matter where you put it. Some people prefer to put the private section first, as long as you label the section private. Technically, you don't have to, because if you put just everything with no private section labeled, by default, members of a class are private, so they will be private. But for documentation purposes, it's best to label which sections private, which are public. You can, in fact, have multiple private and public sections. Like I could do, there are cases where you might have public data members and private member functions, so it's opposite of what we've used so far. You could have completely separate public and private sections for the data members, and then public and private sections for the member functions. It's whatever you really want to do in whatever order you want to do. But in C++, typically, at least I have seen it, some programmers, some developers in Europe, the United Kingdom specifically, prefer putting the private section first. If you prefer doing that, that's fine also, but in C++ it seems to be, by and large, that we put the private section afterwards, because the class knows it's private and public data and member functions regardless of where you put it. So, but customarily we write the private data members under the public member function section. So, all right. So I hope that answers that question. I have posted for session 4 the slides and the session 4 notes, which go over the information from this section. Good questions and good discussion on the discussion boards. Keep it coming. And I will hopefully have the first project posted soon. For those of you who haven't done the homework assignment yet, I would highly recommend doing it. It is worth quite a few points, or at least a few points, so it is worth something. I've only got 8 turned in now, and there are like 40 students in the class, but I believe it's still early. Let's check the date on that just to see where we are. Right here. Yeah, it's due on the 27th at 11:59 p.m. So if you haven't started on it yet, that's fine, but just I would say start on it as soon as possible. There are 4 questions, and the 4th question is multi-part. So it's not really that difficult, but it's easy points if you will just do it, right? Okay, so on to the topics of today's session. Again, we're in Chapter 5 in the DoWhile 9th edition book. I believe also the 8th edition, it's the same, essentially the same material, so if you have the 8th edition, that's fine as well. Should work. The topics that we'll cover today, or that we covered last week, were the control structures. We started with sequential control structures, which we've used before. We're actually very familiar with sequential, even though we didn't call it that. That's when you just write commands in sequence, so sequential control, or linear control structure. The other 2 categories of control structures that we covered were selection control structures, also known as branching control structures. This included the if single selection control structure and the if-else double selection control structure. And of course the if-else can be cascaded, in which you write if, and then a section, then else if, then some condition section, else if, etc., etc., and then a default statement going in the else section. That's if all the other if-else or else-if sections don't satisfy the condition for any of those are not satisfied, it will go to the else section. That is optional to have an else section, but we still consider if-else a double selection structure because even though we can use multiple scenarios, they are nested or cascaded. Okay, so you can put them inside. You can put one if statement, one if-else statement inside another if statement or else section or if-else section. That's called nesting. And if you have them all at the same level and you write else if and then a section else if, we call that cascading. But it really is the same as nesting ultimately. The other category of control structure that we covered were the repetition or iteration control structures. The specific one that we covered was the while repetition structure, the while loop. So that's what we covered this last week. We covered 2 selection control structures and 1 repetition or iteration control structure. This week we're going to cover 2 iteration control structures and 1 selection structure that's left. So we'll start a new project and take a look at a new repetition control structure. Again, we're in C++, we're doing a Win32 console application. I'm going to call this session 4, loops and selection. Again, I check empty project and click finish. And wait on it. Alright, so I get my empty project here. I'm going to add a source file, and to keep things simple, we're going to just use a simple source file, CPP file, and I'm going to write the skeleton program like I always do. Okay, so we've got the main function here, and we're including IOStream because we're going to be printing and interacting, because that's the only real way we know if our program is working. Now, your program will happily perform calculations and do stuff with the numbers and do whatever you want without telling you a thing. The program doesn't care. It's like the honey badger. It really doesn't give a crap. So, but in our scenario, what we want is we want to see it actually doing work for us. So the for loop is what we're working with this time. So what I'm going to do is I'm going to show you the general syntax of the for loop. With a while loop, well, I guess we'll start with that. We declare a counter outside, and then we say, for example, while count less than 10, and then cout count plus plus. This is the repetition statement we dealt with last week. So we initialize the counter outside the loop, then we test the condition, while count is less than 10. So as long as count is less than 10, we call this the loop continuation statement. Loop continuation statement. If the count gets to the point where it is no longer strictly less than 10, we will break out of this loop. Okay, so let's build this and run it. And nothing new here. This is what we did last week. Until it builds. Okay, good. And I'm going to run it. And we'll note that it prints out what we expect. Goes through the loop, and each time it increments it and moves towards the termination condition. When it eventually gets to 10, it will break out of the loop. Okay, so that's the while loop. Now, while loops, although it's perfectly acceptable to use them in this fashion, while loops are arguably better for sentinel or flag controlled loops. So a essentially infinite loop until you enter a sentinel value. So if I asked for grades, percentages for tests or something, and I was supposed to calculate the average for a class, class grades, I could say enter a valid number 0 through 100, and if you want to exit the loop, press or type -1. So anytime the user types a -1, which is the sentinel value or the flag, we will break out of the loop. So while loop's really good at that. Now you'll notice that this is kind of broken all over the place though when we try to use a count control with the while loop. We've got the declaration up here, the test condition here, and we're moving towards the the termination of the test condition right here. So in C++, we have a special type of loop that is perfect for count control. It's called the for loop, and I will show you what we're doing here. All right. So first of all, the header of the for loop has pretty much everything we need. We have the declaration of the count control variable. This is only executed once when you first enter the loop. This right here is there's a semicolon, notice, after that. This right here, the middle, is a test. We're testing as I less than 10 this iteration. And then each time it goes through the loop, it increments I by 1. Now, could I name this count? Yes, you can name it count, you can name it sausage, you can name it horse. It doesn't really matter. But this essentially does the same thing as our while loop did before. But the for control structure, for repetition control structure, is perfectly suited for count control repetition, because everything's up in the header. You do everything in the header. Now you can treat this like a while loop if you wanted to, but it's kind of a dumb thing to do. I could delete this and delete that. For example, I could get rid of this, but notice the semicolons are still required. I could declare the I outside the loop if I want to, and then do I++ here. So this makes it look a lot more like a while loop. And it still does the same thing. Okay, you do have this option to write it this way, but it is not really a good idea, because it's preferred that you use it the way it's intended to be used, which is as a for loop. Okay. All right. So it's a lot more compact, and it's better for count control. So that's the for loop. That's perfect for count-controlled repetition. So which iteration statements are we aware of now? Which repetition control structures do we know? We know the while loop, and we know the for loop. There's a third one available in C++ called the DoWhile loop. Okay, so here's the syntax of the DoWhile loop. Again, you declare the counter outside the loop, but then you write the word do. Notice there's no curly brace. And then after the closing braces, I do the test. So I can say counter less than 10. And then notice this is a very, very important part of a DoWhile loop. You put a semicolon after the while here. Now the reason for that is because if you don't, it's going to be ambiguous. If I wrote something like this, this would get really, really confusing. We're not sure what's going on. That doesn't make sense. So we have to show right off the bat that this is part of a DoWhile loop. So in here, I'm going to print out the counter. And also I have to move towards the termination condition, just like I do in the regular while loop. Alright, when I print it out, I get the same thing that I would if I was using a regular while loop. Well, you might ask, well, why is it useful? Why is that useful? Well, let's look at something. Okay, we've got counter set to 0, and let's say while counter is less than 0. All right. Now, if I run this, notice it does print 0. Okay. With a while loop, okay, if I just comment this out for a second, oops. If I comment this out for a second, just give me just a second here. This is useful to you guys because I don't have everything set up set up on here yet. There's usually a comment button. Here we go. Comment out the selected lines right here. I'm going to move it down here because I normally keep it down here. Okay. They changed the icon for it. All right. So I do that and it comments out the whole thing. Okay. Exactly what I want. So while counter less than 0. So this is a regular old while loop here. Okay, let's see what happens if I use this one. Nothing. It doesn't print out anything. It just shows the press any key to continue, but as we know, that's not actually part of the program itself. So, what's the difference? The DoWhile iteration statement is guaranteed to execute at least once. If you'll notice with the while loop, if I declare and initialize the counter at 0, then I do the test here with a while loop, counter less than 0. Well, 0 is not less than 0, so it never even makes it into the loop, correct? Let's delete this and let's uncomment this. With the DoWhile loop, however, even though this condition will immediately evaluate to false when we get here, the DoWhile loop, the body right after do, will execute once. Then the test will be performed to see is counter less than 0. Then it will break out. So that's why when we build and run this, it does actually print out once. Because before we got to that termination condition, we did print out the counter, increment the counter. Now the counter is 1. So is 1 less than 0 is actually what it's testing. It says no. Okay. So that's the DoWhile loop. So now we know the while loop, the for loop, and the DoWhile loop. The next thing I want to cover is the switch case statement. All right. So the switch case or switch multiple selection statement is perfectly suited when you have multiple integers that you're taking into consideration, or one integer that you have multiple cases for. So for example, let me declare an integer here, put it at 0, and I'll say please enter an integer. Okay. Then I wait for the user to enter the integer, and now I'm going to use the switch case on it. Okay, so that's the end of the switch statement. I can write case 1, the student got an A, and notice I put a break statement. Case 2, the student got a B. Notice it lines it up automatically as we're typing too. D. And then there's a section called the default section. This is if everything else fails. We'll just say student failed the course. Now, if none of these cases are true, the default case will execute. Now that's sort of like the else in a series of if-else statements. But this is pretty compact, you'll agree. The break is important, okay, because as soon as it meets a criteria, we want it to get out of the switch statement, okay? Now, so this might be kind of a funny point system, but let's say that these are like rankings more than points, because normally you might see a 4 means an A and a grade point average, or a 3 means a B. But here, let's say that the lower the number, the better. Okay, let's enter a 2. Says the student got a B. All right, that's what we expect. Let's say, let's enter a 4. Student got a D. That's what we expect. And let's enter an integer. Let's say the student got a 5. Student failed the course, right? That's exactly what we expect, because 1, 2, 3, and 4 are not integers that match the integer that the user entered. So that means that it will print out student failed the course, then break. All right, you can use the switch statement inside of a loop if you wanted to. You can put loops inside the switch statement, okay? You can mix and match all of these different selection structures, and they're very, very useful. Okay, so now, as far as selection control structures are concerned, we know the if single selection structure. That's basically you do an if statement to test, if something's the case, and you either do it or you don't. We have the if else double selection control statement, okay? And what that does is it will give you one of 2 options, essentially. Now, again, you can nest them, you can cascade them, but ultimately you're either doing what's in the if section or you're going to the else section. And you can link them together, cascade them, or nest them. So I could have else if, right? Which we looked at last week. Now, this third one that we learned is the switch controls. The switch selection control structure. We call it a multiple selection control structure because it lets you, it's perfectly created to select between multiple options. Okay, this is built for this. You'll see this a lot in scenarios like in game design. These are used very frequently because they're a little more compact. So if user hits up arrow key or W on the keyboard, you want them to go up. If they hit the S or the down arrow key, you want them to go down. So I would switch on the input from the mouse essentially, or not mouse but the keyboard. And if the key is equal to W, then I go up. If it's S, I go down, etc. So that's pretty much what we need for the switch statement. So we know the if single selection statement, the if else double selection control structure, and the switch multiple selection control structure. That's for the selection control structures. We know how to write sequential code. We've been doing that for a long time. This is sequential code. And we know how to write the 3 iteration or iterative or repetition control structures, which are the while loop, which we learned last week, the for loop, which is perfectly made for count control repetition, and the DoWhile loop, which is guaranteed to execute at least once. Okay, but it's very much like the while loop. So that's pretty much for the control structures. A couple other notes we need to make are about break and continue. So let's look and see what happens here. Let's use the for loop since that's new to us. And say I less than 10, I plus plus. I told you that you could write selection control structures or even other repetition control structures in a for loop if you want to. Let's do a couple different things here. First thing I want you to do, I want us to see, is let's look how to make a box here, a 10 by 10 box, using 2 repetition control structures. Notice I'm changing the variable name, because if I used I, it would conflict with this outer I here, and it wouldn't know which I was talking about. So let's do a 10 by 10 box of asterisks. So what I'm going to do is I'm just going to write a star, okay, an asterisk, in quotes. Notice I do not have an indel here because I want them to write 10 in a row, and then after it's done writing the first row, I'm going to print out a new line. Okay, see how this works. When we first entered this outer loop, I is equal to 0, and then 0 is less than 10, so that's correct. And then what we do is we go into this inner loop. J is 0, print it out, then J is 1, print it out, 2, 3, 4, 5, 6, 7, 8, 9. And then when it gets to 10, it will break out, and it will not continue with this loop. It'll go immediately to here, which will print out a new line character. Then it will go to the top of this outer loop here. Okay, this is called nesting loops, nested loops. This outer loop will now increment I to 1, and then J is reset to 0, and then it's 0, 1, 2, 3, 4, 5. So what we're going to do is we're going to get 10 stars on the first line, 10 stars on the second line, third, fourth, fifth, all the way up until this outer loop is done. When this outer loop terminates, then we're done and we return 0. So let's see what that looks like. Okay. So looky there. We have a 10 by 10 here. This looks like it's taller than it is longer, but that's only because it puts extra space in between the lines. We could make it look probably a little bit more even by adding an additional space there. See if that helps a little bit. Yeah, a little bit. Right? Okay. So that's how you use nested loops. Right? Another thing that we can do is we can use the break and continue statement. So I want you to be able to see what these do. First things first, if I just print out I here, it's going to do what we expect, right? It's going to print out 0, 1, 2, 3, all the way up to 9. Okay, that's what we expect. Now, if you have a special number, maybe this kind of makes a trivial example, but let's say that before this cout statement, if I is equal to 4, we type break. Let's do break first. Okay. We saw break in the switch statement, but it takes on a little bit of a different connotation here. Let's see what it does. Okay. When I run it, notice that it does not print 0 all the way up to 9. We stop at 3, because the first time through the loop, I'm testing this condition, but also in this if statement, I'm testing that condition. So when it gets to 0, is 0 equal to 4? No. Keep going. Print it out. 1, 2, 3. But when I is equal to 4, even though this condition right here is satisfied, when it gets to here, we call a break statement. And what break causes to occur is whatever loop you were inside, the innermost loop that you were inside. Now, this is not a loop, remember. This is a selection statement. This is not a loop. This is a loop. Okay? So whatever repetition statement you were inside, break will cause it to break out of the loop entirely. So when you get to 4, it breaks, it does not continue with this statement, and it ends up here. So if you did anything after that, it would do that and then return 0. But right now, that's all we're doing, so it's just going to immediately go and return 0. Now, that's the break statement. Another handy statement is called continue. Notice it turns blue also, because that's a keyword in C++. Let's see how this is different from the break statement. Let's continue. 0, 1, 2, 3, 5, 6, 7, 8, 9. So what happened here? What's missing? Okay, this is like Dora the Explorer. Help me find what's missing. Oh, a 4, you say? Yes, a 4, because as soon as it gets to the 4, we call the continue statement. What continue says is anything past this line, don't execute it and go up to the next iteration. Okay, so basically you start over at the header again as if we had gone through the whole loop and we start again. So it increments or decrements or what have you, executes the this statement here, the I++, and then it continues. Okay, so break immediately stops what you're doing inside of a loop, and continue causes us to start over at the beginning. Or not start over, but go to the next iteration. Okay. So you might think, well, what could that be useful for? Well, let's make this a little bit more complicated here. I'm going to say if I modulus 2 is equal to 0, continue, and let's see what happens. Okay, we're performing a little bit of arithmetic here, and we'll see what kind of special stuff happens. Well, look what it's printing. 1, 3, 5, 7, 9. What's it skipping? The even numbers, right? And let's think about why it's doing that. Why is it skipping the even numbers? Continue causes us to skip this little print statement here and go up to the top. What does this mean? What does this I modulus 2 equal to 0? Well, remember what the modulus operator does. We have addition, subtraction, multiplication, division, and modulus. Division returns the quotient from a division problem, correct? The / returns the quotient. So if we say 4 divided by 2, it returns 2. What this means, though, with the modulus operator, I modulus 2 is saying if I is divided by 2, it returns the remainder. So let's say that the number that we have here is 0. 0 divided by 2 is 0. So 0 equal to 0, we continue. So we don't print out the 0. We go up to the top. I is now 1. 1 modulus 2. If you divide 1 by 2, you get 0 as the quotient, but you have 1 left over. Okay? So this is not true, so it does not execute the continue statement. We print out 1. The next time through the loop, we have I equals 2 this time. 2 divided by 2 is 0. Okay, remember modulus is 2 divided by 2 is 1, but the modulus is concerned with the residue or the remainder. So 2 modulus 2, since there's no remainder from that problem, it equals 0, so we continue. What is the definition of an even number? What is the definition of an even number? An even number is a number that you can divide by 2 and have no remainder, correct? That's the very definition of the number. Now what if we wanted to print out all odds, or all evens, instead of odds? Well, you're going to say if I modulus 2 is not equal to 0, and let's see what happens. Alright, so now we have the even numbers, 0, 2, 4, 6, 8. Pretty cool? Nice. Okay. So that's the break and continue statements, and also a little bit of cleverness with the modulus operator. Okay, the next thing I want to cover, I'm going to open up Excel here, because I want to show you some things. I want to go over the logical operators. And the logical operators are useful. The logical operators are useful if we want to combine statements or have multiple statements that execute. So for example, if we want two things that have to be true, both of them have to be true to do something, then we use AND. If one or the other is sufficient, we use OR. Okay, so let's start here. For AND, which is this operator right there, let's say we have two variables. Here we're going to have P and Q, right? And then we're going to have the statement P and Q. So true, true, false, true and false, false and true, and false and false. These are the only possibilities we have. All right, so I'm going to make that a little bit bigger. Okay, so if both operands are true, then this whole statement is true. Otherwise, they're all false. So even if one of them is true, as is the case with these two, with the AND logical operator, they are false. So both have to be true. We'll look at some concrete examples in just a second. In C++, the OR is represented not by two AND symbols, but by two vertical bars, which are above the enter key next to the curly brace. It's where the backslash is. You would hold down Shift and hit the key that the backslash is on, and it prints out the vertical bar. We have P and Q again, and then we have P or Q. All right, true, 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 false, false, true, false, false. So if you only have two operands, these are the only possibilities. Now the T and the Fs are are true and false, obviously. Now, if true or true, if one of them is true, the whole thing's true. True or false, well, that's true. False or true, true. False or false, false. Because one of them has to be true. So these are the two tables we have. These are called truth tables. The AND logical operator says that both of the operands have to be true. The OR logical operator says that only one of, at least one of, the operators has to be true. That's why this one's true, this one's true, this one's true, and that one's false, because neither of them are true. Okay? So let's look at a concrete example in here. Let's say we have age and char G, okay, or we'll say gender. Okay. All right, so let's say that we are organizing a company here. It's a bingo club for women who are over 40. Okay, so if the age is greater than 40, we said over 40, so you have to be at least 41, and gender is equal to F, then we say, welcome to the club, come in. Okay. Otherwise, we print out, sorry, go find a club of your own. Okay. So, let's see. Let's see why this is doing this. Oh, yeah, that's important too. Don't use the single equal sign for is equal to. That's actually in the book, and I ironically messed it up myself. Isn't that funny? Okay, so I got to typing and wasn't paying attention. You have to use the double equals sign to test if one thing is equal to another. To assign a value, use the single equal sign. Okay, so what we're saying here is we're saying if the age is older than 40 and the gender is equal to F for female, we're using a character to represent that. Then we say welcome to the club, come in. Otherwise we say sorry, go find a club of your own. Okay, so let's see if this works. All right. It'll say sorry, go find a club of your own. Well, you might ask why. Because our person's obviously female. Aren't they allowed? Well, no. Because the age is set to 0, and it says is 0 greater than 40. Since that's false, it doesn't even bother evaluating the second one. That's called short-circuiting. So if you're familiar with the term short circuit, in this case, it's only if this one's false, the runtime environment knows it doesn't even have to test this one, because with AND, both of them have to be true. If this one's true, it goes ahead and tests this one. Okay, so let's try this. Let's say 41. We're going to build it, and then we're going to run it, and it says welcome to the club, come in, because 41 is greater than 40. That's true, so it will test the second condition as gender F, and it is. So it says come in. Let's change the gender. Okay, we'll keep it at 41. Let's make it 45. We'll make it 45, just to make it interesting. Build it. Run it, and it says, sorry, go find a club of your own. Well, even though our user, or the age, is 45, which is greater than 40, it evaluates that to true. It will test the second one, which tests the gender, and then since M, for male, is not equal to F, which represents the female, it does not let the user in. Okay, so that's AND and OR. Okay. The next thing that I'd like to do is I'd like you to do a study on your own for a little bit. So what I'm going to do is I'm going to explain the problem, and it's slightly more complicated than the examples I've been giving, but I want you to try to do it on your own, and then come back and we'll do it together. The particular exercise, if you have the 9th edition of the book, the particular exercise I'm interested in is in Chapter 5 on page 197. Chapter 5, page 197. It is the one labeled bar chart. Okay, 5.13, bar chart, 5.13. I will read it to you in case you don't have this particular version of the book, and you should be able to, I would recommend putting aside maybe half hour and trying to do this, maybe 45 minutes if you have to read a little bit. This is similar to what I would do in class. We'd probably take anywhere from 20 to 45 minutes to work on a problem or two. So what I want you to do is I want you to do this problem and try to see if you can get it on your own. Don't cheat. Don't look ahead, because part of learning, or part of the most learning you'll ever do, is by messing up and not getting things right. So you will feel a greater accomplishment if you try this on your own as well. So 5.13 on page 197, bar chart. It says, one interesting application of computers is drawing graphs and bar charts. Write a program that reads 5 numbers, each between 1 and 30. Assume that the user enters only valid values. For each number that is read, your program should print a line constraining the number of adjacent asterisks. For example, if your program reads the number 7, it should print asterisk, 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 asterisk. Say that 7 times fast, because I just did. If you read the number 7, it should print 7 asterisks in a row, basically. So you're reading in 5 numbers. So I'll give you a hint before you start. You're reading in 5 numbers. We haven't covered arrays yet, which will help you out with this future. So if you're familiar with arrays in Java, don't try to do it yet. Just make 5 separate variables. You can name them pretty much whatever you want, as long as it's a valid C++ identifier. You could say num1, num2, num3, num4, and num5 if you want. And you can have the user enter them. You can prompt them for each one of them individually, or you can ask the user to enter 5 numbers separated by spaces and use a CN statement like this. Actually, you can do something like this: CN age, and then age 2, age 3, etc. like that. Okay, you can do it that way as well. So I want you to work on that. Again, it's just so maybe if you need the text here, it's on page 197, 5.13. Again, I'm going to read it one more time. One interesting application of computers is drawing graphs and bar charts. Write a program that reads 5 numbers, each between 1 and 30. Assume that the user enters only valid values. For each number that is read, your program should print a line containing that number of adjacent asterisks. For example, if your program reads the number 7, it should print out 7 asterisks in a row, right? Okay. So again, you're reading 5 numbers. I would recommend using a nested for loop for this. Okay, so you're going to be using a nested loop. That would be my recommendation. One of the loops, the inner loop, will take care of printing out the particular number of asterisks for that iteration, and the outer loop will be how many numbers did you ask the user for? For example, 5. So we'll loop through 5. So what I would recommend is you pause the recording and take about anywhere from 30 to 45 minutes to work on this, and we'll come back and take a look at it. Okay, so hopefully you've taken a few minutes to look over this particular problem, and it is a little bit sneakier than it seems. If you're not using arrays. If you're familiar with arrays, it's actually pretty straightforward, but this really does challenge your ability to solve problems, specifically using iterative and selection control structures. So I'm going to read it one more time, and then we'll do it together. So bar chart, 5.13 on page 197, bar chart. One interesting application of computers is drawing graphs and bar charts. Write a program that reads 5 numbers, each between 1 and 30. Assume that the user enters only valid values. So basically, with that statement, they're saying we don't have to test, to make sure they're entering a character or something else. We can just take the number and use it as is. For each number that is read, your program should print a line containing that number of adjacent asterisks. For example, if your program reads the number 7, it should print 7 asterisks in a row. Okay, so here's what we're going to do. We're going to declare 5 integers. Okay, we have num1, num2, num3, to num4, num5. Okay. Now, there are a couple different ways you can interpret this particular program, and we'll do it a couple different ways just so we know there are multiple ways to interpret this, because I think in some ways it might be a little bit unclear. So here's a couple different ways we could do it. First way we could do it is with 5 separate integers, and then we print the corresponding bar charts all as one group. So here's how I would do that. First things first is I would say we know there are 5 of these, so I'm going to say I less than 5. All right, so this is the outer loop that will determine which iteration we're on. Are we on num1, num2, num3, num4, or num5? Okay. So the other thing we're going to do is I'm going to say enter 5 integers to the user. And we're going to do this: num1, num2, num3, num4, and num5. Okay. Then inside this loop, before we do additional looping, we need to know which one of these 5 we're on, which one of these 5, because these will be 5 different integers that the user enters. So I'm going to have an integer called num stars. Okay. And if the iteration of the loop we're on is iteration 0, in other words, if I is equal to 0, then num stars is going to be set to num1. Else if I is equal to 1, the num stars is going to equal num2. 2, num stars is equal to num3. Else if I is equal to 3, if we're on this essentially the 4th iteration, num stars is equal to num4. Else if we could just put an else here because it's the only other possibility, but I'll use it directly. Oops. Stars equal to num5. Okay, so this helps us determine which one we're actually going to be using for the inner loop. In this inner loop, we're going to say j equals 0, j less than num stars, j plus plus. Okay, so we're going to print out a star for each one of these. No end line at the end of each star. Until it gets done, then you print out an inline. All right, so let's do this. We're going to run it. Please enter 5 integers. Between 1 and 30 we know, so I'm going to put 3, 15, 7, 8, and 20. When I hit enter, it's going to print the different bar charts. Okay, pretty cool. Since we didn't, I'll let you look at this code for a second, but since we didn't really get clarification as to when we should input these 5 numbers, it just says write a program that reads 5 numbers. Assume the user enters only valid values. For each number that is read, your program should print a line containing that number of adjacent asterisks. So there is another way to interpret that problem. This is slightly more complicated, but it's also, it gives us a wider range of ideas about how we would use the if statements inside of a for loop. with multiple options, and then a second for loop down here. So we're using nested for loops, and also a series of if statements. Let's assume that we interpret it a different way. Let's assume this time that we're only going to input a number, have the user input a number, and then output the asterisks, then input a number, then output the asterisks, then input a number, then output the asterisks, etc. So we're just going to say int input equals 0, and since we know that we only need one of these variables because we're going to reuse it for the 5 numbers, we know that there are 5 numbers in total, and we're going to say please enter an integer and input integer j is equal to 0 while j is less than input, j++. Then we're going to print out the asterisk, and then print out the inline after that's done. So this is a lot more compact, but it will prompt the user, and it won't put the bar charts next to each other, directly next to each other. So let's build this, and we're going to start with that debugging. And this is the first time the loop. It says, please enter an integer. I'm going to put 15. It prints out 15 asterisks. We'll put 2, prints out 2 of them. 20, prints out 20 of them. Even 29, prints out 29. Please enter an integer 5. And now we're done, because that's gone through all 5 iterations of the outer loop. Okay, so this is probably the way they intended on the user, the reader, to interpret the instructions, but I showed you a couple different possibilities because the requirements were actually a little bit unclear. So, as far as I'm concerned, they were unclear. Alright, so that's a pretty solid example. So, that's pretty much what I have for you this week. I would recommend interacting on the discussion board if you have any questions, or if you have any specific questions for me that are more personal or you think only maybe apply to you, then feel free to email me at jpbaugh@oaklandcc.edu. Again, it's jpbaugh@oaklandcc.edu. I appreciate you joining me this week, and I hope that you study up and start interacting with your colleagues as well. I don't mind people assisting each other a little bit as long as it's not on a test. You can feel free to post your questions on the discussion board and interact with each other in the general discussion, whatever you need to do. So if you have any questions, post them on the discussion board or email me, jpbaugh@oaklandcc.edu. All right, thank you and have a good week. Bye.